Let's look at the next question. The next question that we do is question number 11. It says if AB is equal to BC and AD is perpendicular to CD, we need to prove that AC square is equal to 2 times BC dot DC. So we have two right triangles. Let's try and see if we can get this question done. So in a right triangle ADC, using Pythagoras theorem, we have AC square is equal to AD square plus CD square. Now CD is nothing but BD plus BC, so let's replace CD with BD plus BC whole square. Reason for this, since CD is equal to BD plus BC. So that's all we've done till now. Let's open this bracket and see where does this lead us. So this is AC square is equal to AD square plus BD square plus BC square plus 2 times BD dot BC. Just open this bracket in the form of x plus y whole square. Now AD square plus BD square, if I look at the small triangle ADB, would be equal to AB square. So this is AB square plus BC square plus 2 times BD dot BC. The reason for this, since in a right triangle ADB, using Pythagoras theorem, we get AB square is equal to AD square plus BD square. So that's the only thing we've done. Next, I've already got AC square on one side. I need to convert all of this into 2 times BC and DC. So AB square and BC square. Since AB and BC are equal, I can write, instead of AB, I can write BC square. So this is BC square plus BC square plus 2 times BD dot BC. The reason for this, since AB is equal to BC. Next step, this is AC square is equal to 2 times BC square plus 2 times BD dot BC. Now in these two terms, 2 times BC is common. So if I take 2 BC common, what remains in the first term is BC and what remains in the second term is BD. So this is 2 times BC dot BC plus BD is nothing but DC. So this is the right hand side. That's exactly what they wanted us to prove, that AC square is equal to 2 times BC dot DC. The same question can be solved using the X method as well. The only thing, you will need to take this as the X, where you working with algebra. You could take any other elements. You could take this as Y, this as Z and H. If you work on this, you would still get the same answer. Let's look at the next question. The next question that we do is question number 12. So question number 12 says, in an isosceles triangle ABC, AB is equal to AC and D is a point on BC produced. So let's just draw the rough diagram. So this is an isosceles triangle, A, B and C. These two are equal. Next, they are asking us to produce BC towards C, and this is point is D. So let's join A with D as well. Next, we need to prove something, but where is the right angle triangle? So let's just construct a line which is AE perpendicular to BC. Now since this is an isosceles triangle, the altitude will be equal to the median as well, which means BE and EC would be equal. Yes, BE and EC would be equal. So let's just write what we did. So point number 1, construct AE perpendicular to BC. What this means is BE would be equal to EC. Let's call this Y. Yeah, let's call this Y. Let's call AB and AC X. The reason for this is, in an isosceles triangle, altitude divides the base in two equal parts, or bisects the base, whichever way you want to write it. So this is done. Next, AB is equal to AC is equal to X. Any other value that we've taken? Yes, let's call CD as Z, let's call AD as L, and let's call AE as H. So this is point number 4, CD is equal to Z, point number 5, AD is equal to L, and point number 6, AE is equal to H. Next, we've done this. Let's see what do we have on the what do we have to prove. So left hand side is equal to AD square, which is equal to L square. Now in a right triangle AED, using Pythagoras theorem, we get AD square is equal to AE square plus ED square. What it means is L square is equal to AE, which is H square, plus ED is nothing but Y plus Z whole square. So this is H square plus Y square plus Z square plus 2 times YZ. Let's just check. H square plus Y square plus Z square plus 2 times YZ. This is fine. So yeah, so H square, this is my left hand side. This is equal to left hand side. Let's see if we can convert the right hand side to the same element. So right hand side here is given as AC square plus BD times CD, which is AC square. AC square is X square. BD is nothing but 2Y plus Z, and CD is Z. Now X square can be written as H square plus Y square. So this is H square plus Y square, plus if I open this, this becomes 2 times YZ plus Z square. The reason for this, since in right triangle AEC, using Pythagoras theorem, I get AC square is equal to AE square plus EC square. So what we have as the right hand side is equal to H square plus Y square plus Z square plus 2 times YZ. So from 11 and 15 we get LHS is equal to RHS. So hence proved. Now let's look at the next question. The next question that we do is question number 13. Yes, question number 13. It says in triangle ABC, angle A is equal to 90 degree. Okay. Let's just draw a rough diagram. D is a point on AB produced. Okay, so okay, fair enough. So this is angle A, 90 degree. This is D produced on AB, and this is point C. And CA and AB are equal. Next, we need to prove that DC square minus BD square is equal to 2 times AB dot BD. Perfect. Let this be X. This is also X. This is Y. This is L, and this is Z. Number 1. Let AB is equal to AC is equal to X. Number 2. BD is equal to Z. Number 3. BC is equal to Y. And number 4. CD is equal to L. Let's see how this helps us. On the left hand side we have DC square minus BD square. So DC square minus BD square. So point number 5, left hand side is equal to DC square minus BD square. Now DC square is L square minus BD square is Z square. L square can be written as X square plus X plus Z whole square, and this is L square and this is minus Z square. The reason for this, since in a right triangle ACD, using Pythagoras theorem, I get CD square is equal to AC square plus AD square. This is fine. So what I have is left hand side is equal to x square plus z square plus 2 times xz minus z square. Negative z square and z square gets cancelled. So what I have here is 2x square plus 2 times xz. That's our left hand side. Let's see what if we can reduce the right hand side also to the same value. So right hand side for us in this question is given as 2 times AB dot AD, which is 2 times AB, which is x, and AD is x plus z, which means right hand side is equal to 2x square plus 2xz. So from 9 and 11 we get LHS is equal to RHS is equal to 2x square plus 2xz. So hence proved. Done. Let's look at the next question. The next question that we do is question number 15. So question number 15 says, in the following figure, AD is perpendicular to BC. Already shown, D divides BC in the ratio 1:3, which means if BD is x, BC in the ratio 1:3, so if BD is x, then CD is 3x. That's fine, that's what the question means. And we need to prove 2AC square is equal to 2AB square plus something. Let's take variables, so let this be H, let this be L, and let this be M. So point number 1, since BC divides, since AD divides BC in ratio 1:3, therefore let BD is equal to x, therefore CD is equal to 3x. Next we have AD is equal to H, point number 5 AC is equal to M, and point number 6 AB is equal to L. Let's see what do we get from here. So left hand side is equal to 2AC square. AC is M, which means 2M square. So M square can be written as, instead of M square, I can write H square plus 3X whole square. Reason, since in right triangle ADC using Pythagoras theorem, we get AC square is equal to AD square plus CD square. So that's the reason for this, which means left hand side is equal to 2 times H square plus 3X whole square, that's 9X square. Yes, that's 9X square. So this is equal to 2H square plus 18X square. So that's our left hand side. Let's see if we can reduce the right hand side also to the same thing. So let's work with the right hand side now. So right hand side is 2AB square plus BC square. AB is L, so this is 2L square plus BC is X plus 3X whole square. Let's see if we can change L into H. Yes, so we can write L square is equal to H square plus X square. So point number 12, right hand side is equal to 2 times L square can be changed as X square plus H square, and the second part, which is X plus 3X, that's 4X whole square. Reason for this, since in right triangle ABD using Pythagoras theorem, we have AB square is equal to AD square plus BD square. So that's the reason for this. Next, right hand side is equal to 2 times X square plus 2 times H square plus 4x whole square, that's 16x square. So this is equal to 18x square plus 2h square. Is this equal to my left hand side? Yes, 2h square plus 18x square and 2h square plus 18x square. So from 9 and 14 we have LHS is equal to RHS is equal to 2h square plus 18x square. So hence proved. Done. That finishes this chapter for us. One question for you for homework. So homework question for you would be question number 14. Done. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.